I could probably move my camera over there. Let's see.
I think, yeah, this direction.
I think I'll leave it here because if I move the camera, then I won't be able to.
This direction is fine.
Yeah, there we go. Let's do it that way.
That's our last session for this course.
Yeah, that's right. For this cohort, this is it. So all of you are going to be graduating here pretty soon. So wow, great.
Starts.
All right. Excuse me. Let me get a drink of water here real quick, and then we'll get started. 1 second. Okay, now obviously, well, first of all, welcome everyone. We're not going to be able to cover all the different protocols. We looked at diameter, I'm sorry, we looked at SS7, the Signaling System 7. And SS7 is the protocol that's used to communicate within mobile networks and between mobile networks for second and third generation mobile networks. It's also used for circuit type of services. For example, short message service is delivered for the most part with SS7. It's also used for setting up circuit switch voice paths between, let's say you use your mobile phone, you call someone to send a wireline network or some, there's that setting up of that voice path. That's SS7 does use that. By the time you get to fourth generation, you're using a different protocol, and that protocol is called diameter. And we'll take a look today a little bit at diameter. GTP, GPS Tunneling Protocol, is think of it like a VPN, like a virtual private network. It's a packet within a packet. So your data packets, as you type out www.anywhere.com, that data goes inside of these tunnels, like a VPN tunnel, and then it's sent out to the network. So those tunnels get set up in these data networks. SIP is a call setup protocol for voice over IP. So again, your mobile phone, it sends this SIP protocol through these data tunnels and out to the world. HTTP2 is what's used in fifth generation networks. So diameter is very much a 4G. It's used in the other optional architecture, which we call the IP multimedia subsystem. But for the most part, diameter kind of comes in on 4G and it leaves just as quick with 5G. 5G, all of that gets replaced with HTTP2. So we finished up here. We finished up talking about wrapping up on SS7. SS7 is used in all 2G, 3G networks, and it does these things. It's also used to set up voice calls. It's also used for other applications like number portability, short message service. Very, very widely deployed and very deeply entrenched inside these networks. And it's a legacy protocol, as is these other protocols. Diameter, what diameter is used between, now remember on a 4G, we talked about this in the previous lesson. This is the architecture of a 4G network. So you power on your mobile phone, you have your radio interface here, and you have communication to this other device called the mobility management entity, which think of it as taking the place of the mobile switch that's in the 2G, 3G network. Well, the communication between this device and the home subscriber server, which is like the HLR, the equipment identity register, conveying policies where you can apply different quality of service, different guaranteed bit rates depending on your data stream. Those are called policies. All of these things use diameter. So instead of SS7 doing that, it's been replaced pretty much by diameter. Now, diameter was not written by Telecom, though. Diameter was originally written by the Internet Engineering Task Force. And it was originally written as what's known as an AAA protocol, a protocol that does authentication, authorization, and accounting. So it was written for a purpose when it replaced another protocol called Radius. And that was back at a time in the late 1990s when people that wanted to access this brand new thing called the internet, you had dial take your home phone and you put your phone in a cradle, which would convert the signals into digital signals, and then you would access this new thing called the World Wide Web. But the system had to authenticate you and authorize you. So that was an AAA type of protocol. It's called Radius. Well, by the late 1990s, there were newer accesses into, you no longer needed dial-in. You could have things like DSL or ADSL. So you could go directly now from your computer into the internet. So Radius was upgraded to Diameter. And Diameter, the reason that 3GPP, the reason the telecom companies use it in 4G is because it's a very kind of a back and forth protocol. It's very much a request answer protocol. Hey, I need something, here it is, we're done. Hey, I need something, here it is. It's just a very kind of a simple protocol that just goes back and forth between these two devices or these two devices. So there's not routing anything here. It does route, but again, it's a different mechanism for routing, whereas a 7-bit. So again, it has a lot of uses. So originally it was a protocol that did authentication, authorization, and accounting for these dial-in access. So you would dial in, and the telephone network would be servers, and these servers then acted like clients. They were servers, and that would be the AAA protocol where it authenticated you and authorized you. So the newer access, like we said, by the late 1990s, early 2000s, there were newer ways to access the data networks rather than dial-in. So that the newer access meant you needed a new protocol, and that new protocol was Diameter. So the Internet Engineering Task Force wrote this protocol called Diameter. It's a base protocol. And the base protocol just does some kind of basic things. But on top of that base protocol, you need some kind of application. So for AAA services, they wrote this application that uses this base protocol. They wrote several other applications also. So again, we don't have to go into each one of those, but the Internet Engineering Task Force, before even 3GPP has Diameter, it's used in data networks. So again, like I said, it's a very kind of a back and forth protocol. I need a request, here's an answer. The answer always contains a result. And the base protocol, just Diameter by itself, it does these 7 things. 1, 2, 3, 4, 5, 6, 7. So the base protocol, that's this right here. The base protocol does just these 7 things. In order to have it do things like authentication, you would need an application on top of that. So the answer always contains a result. If you send out a request, you always get an answer back. The request was successful or it failed or whatever the case might be. Now, look at all these different applications. So some of these applications like this one, and again, we don't have to define them. All of these here were written by the Internet Engineering Task Force. The Internet Engineering Task Force, which is data-oriented, they wrote the protocol for IP. Originally, they're responsible for it. They wrote TCP. They wrote Stream Control Transmission Protocol. Those are the transport layers. They also wrote this base protocol, and they wrote these applications. However, 3GPP now uses that base protocol for some of their own applications. This application deals with the IP multimedia subsystem. Remember that optional architecture that was introduced back 20-some years ago. And it wasn't used until it was used now for voice services or LTE and all data networks. So these 2 applications were written by the 3GPP for that interface, which is in the IP multimedia subsystem, and that interface. On top of that, they wrote that interface, that document, which covers this interface right. Oops. It covers this interface right here, these interfaces. So they write a lot of these other ones, and we won't go over all of those, but Diameter is used for online charging. That's a prepaid service. Offline charging, that's where you get a bill at the end of the month. Policies, conveying policies, and you're applying different quality of service, different bit rates, depending on the data stream, because you can apply these different policies to different data streams. It's used for SMS over within the LTE network, and that's an optional feature. It's used for mobility management here. It's used in the IP multimedia subsystem. So Diameter has a lot of different interfaces. Now, some of these look kind of strange. S6A, S6T, these are just the interface names. Again, I certainly don't expect you to memorize the interface names, but just be aware that Diameter as a base protocol does these 7 things, but it's been expanded now for 3GPP to use them on different interfaces. Because again, it's a very kind of a back and forth protocol. So it first showed up in the IP multimedia subsystem. In the IP multimedia subsystem, and I don't know if you remember these from the first lesson. We had this optional architecture that was introduced at release 5, and it allowed for multimedia services to be used in the mobile environment. And that's something that is used very commonly today, but back in 1990 or back in 2003 or 2004, that was very kind of radical. Well, there's certain nodes inside this IP multimedia subsystem, this optional architecture. There's SIP servers in there, and there's what are known as application servers. And these communicate with the home subscriber server, and that uses Diameter. So this interface here is called the SH interface. These interfaces here are called the CX. So that's the first time Diameter showed up in 3GPP in mobile networks was when they introduced the IP multimedia subsystem. Now the IP multimedia subsystem, when it was introduced, most networks, they didn't use it at all. It's large, it's complex, and there were very few services. Today it's used all the time. Because today it's used because there is no voice, there's no voice services in a 4G network. Everything is data. So you rely on the IP multimedia subsystem to deliver things like voice over IP, or to convert your data, or your voice, which is data, into a circuit switch, and then send the rest of the world. So it first showed up here. It then showed up here. It next showed up in the Evolved Packet Core, which is known as LTE or 4G networks. So when the mobility management entity needs to communicate with a home subscriber server or the equipment identity register locally, or if you're roaming, it communicates with the home subscriber service in your home public LAN mobile network. So it's used in these types of environments also. It's also used here to deliver policies, things like the guaranteed bit rate, things like quality of service. It also is used to support charging. So it has a lot of different applications in 3GPP. This is kind of it's like, wow, look at this slide. This is just to show you a sampling of some of the interfaces. So again, we're not going to go over all of these, but the IP multimedia subsystem communicates with the HSS like we showed with the SH interface and the CX interface. It's also between the mobility management entity, talks to the home subscriber server over that interface. It talks to the equipment identity register over that interface. So there's, again, we're not going to go over all these, but I did this just to show you that in a 4G network, Diameter is used in a lot of different interfaces. Other questions?
Yes. So I was wondering if you mentioned the transport diameter uses.
Yes. Yeah, in other words, on top of IP, the transport protocol will either be TCP, Transport Control Protocol, or Stream Control Transmission Protocol. So either one of these two will be used.
My mind skipped that part. Thank you.
Oh, okay. Yeah, no problem. Well, the thing here, like I said, there's a lot of interfaces that use this back and forth protocol. It's used for charging. It's used if you have backward compatibility with the 3G network. It's used in some cases for a short message. If you have that functionality in the mobility management entity, it's used extensively in 4G networks. It's used to convey policies, charging information. So a lot of different interfaces that use diameter as this back and forth request answer protocol. Let's not worry about the format of it. Just be aware that it's routed via IP. Yeah, please.
Please can we go to the other image? The
What's
previous
that?
one. The previous image.
Oh, previous, yeah.
Yes. So with the S16 and then the S13 are they known as LTE interfaces?
Those are interfaces, yes. So these interfaces are when a mobility management entity needs to update your mobile's location. In 2G and 3G, that mobile switch would have sent an SS7 message. For 4G, the mobility management entity sends a diameter message to the home subscriber server. So that interface is called the S6A. And if it needs to talk to the equipment identity register for hardware identity, it uses that S13 interface. Okay? Sure, absolutely. Any questions, always, please. So again, this is how it routes. It routes to the destination via IP, the destination address and the source address. The transport layer, which defines the ports, is either going to be TCP or SCTP. Diameter will have a header, which just has some information on it. And then the actual parameters, the actual information that you're conveying between these nodes, these devices, they're called attribute value pairs, AVPs. Just like they're called parameters in SS7, the parameters are the pieces of information you're actually sending. In diameter, they're called attribute value pairs. Again, just the name. So you carry different attribute value pairs, these different AVPs that get carried over in diameter for these messages that go back and forth. So diameter is, well, one thing about diameter also is it routes a little bit different. It routes a little bit different. Remember with SS7, how do you route a message with SS7? Through those signal transfer points, those STPs. So the STP actually looks at the destination point code and routes the message based on that STP. Well, the equivalent of that with diameter is called the DRA, the diameter routing agent, or the diameter edge agent. So messages coming in from another network, let's say from here to here, messages coming in from the other network will go through this diameter edge agent. So this is the single point of contact. It'll hide the topology. So if anyone's listening out here somewhere in the world, in the network, they won't be able to know the IP addresses. They won't be able to know how many of these devices here that you have, because this thing hides those IP addresses. It puts phony IP addresses on there. Since diameter is a legacy network, it needs to be protected, just like SS7. So if you have a firewall, which most networks do, if you have a firewall and firewall software and that whole functionality is what one of the things Celsius sells, that would be placed at the diameter edge agent. It does routing, and it's described in some documents. But anyway, think of this this is the equivalent of the signaling system 7 signal transfer point that does the routing. This is its equivalent called the diameter edge agent. Let's not worry about the routing and diameter. Well, I'll mention one thing on routing. In diameter, messages get routed from point to point and they go back the same way. In SS7, application talks to an application. In other words, let's say you're going to do an update location, you're going to update someone's location in SS7 on a 2G or 3G network. That visitor location register in the network where you're currently serving will communicate with the home location register in your home network. So it's the visitor location register talking to the home location register, application to application. Here, you route differently. In other words, you're going to route from here to this point. This thing routes to here. 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 How does it go back? It goes back the same way it came. So you always route the same way that you came. it changes some numbers, they change within the protocol, but you always route to where the message came from, not necessarily the ultimate origination point. Does that make sense? Sure.
Yes. Could that be the reason why diameter is considered unsecure than SS7?
Diameter is inherently not secure either. It's no, really, diameter is a legacy protocol that does not have any built-in security either. So it's a different routing scheme. It's a different routing scheme. So it's a protocol that has to be protected also. Okay, does that make sense?
Yes.
Okay. So that means, like it shows here, responses follow requests. So wherever the response will follow the request, without the knowledge of who really originated this, it just kind of follows that same path. Okay. This is just some reference material. We don't have to worry about that. So diameter is the primary signaling protocol now in 4G networks. The primary signaling protocol in 2D and 3D is SS7. The primary signaling protocol in 4G is diameter, and it is this back and forth, request answer, kind of a simple protocol. And it's used to think of it as similar to what SS7 does in second and third generation networks. This is going to do in LTE or fourth generation networks. Things like mobility, things like authentication, things like location updating and roaming. All this communication between these devices is now done with diameter 4G networks. It's very extensible and it's used over many interfaces. As we saw here, it's used over a lot of different interfaces, or potentially a lot of different interfaces. So it can be used for policy, it can be used for all of these things here, plus it can be used to convey different policies. It can be used for online charging or offline charging. It can be used for other networks accessing the LTE network. There might be a trusted network, there might be untrusted, there might be 3GPP, non-3GPP. There's different types of accesses. Non-3GPP might be a Wi-Fi access or a LAN access or something like that. It's used for the IP multimedia subsystem to communicate with the home subscriber server, and again, it's a legacy protocol. And if unprotected, it is wide open to mischief, or at least potentially can be wide open to mischief. Now, we have time for, I think, just one more protocol left to look at kind of very quickly. And that's delivering data. Yep, please.
Yes. Before you come in, I wanted to know why you refer to it as a legacy. What does it mean?
Legacy protocols, yeah, those are what I mean by legacy. That's a good point. I'm glad you brought that up. A legacy protocol is a protocol that's been around for a long time and written at a time when you never considered authentication, you never considered security. In other words, security wasn't thought of back when SS7 was originally written for wireline networks. No one thought of security. When I first got involved with SS7 back in the mid-1980s, we were just communicating our network. I worked for Ameritech at that time, to large networks, AT&T or Sprint or all these large networks. Well, we trusted each other, and plus there was no useful information. It was just routing information that was being conveyed back and forth. Today, your mobile networks convey your location, your state, your status, and your international mobile subscriber identity. It conveys a lot of useful information. So these protocols are legacy in the fact that they were written 20, 30 years ago. And security was never thought of back then. Back then it was like, okay, we have the protocol, we're just gonna, there's no, these are being used on wireline networks. Diameter was originally written for access into a computer. Today, no one ever envisioned that these mobile phones today would be used like they are today. So it's just by legacy, I mean ones that are written a long time ago.
Okay, so it turns out the concept of the system is the same
Yes.
as applied into the software.
Yes. Now 5G is a little different. 5G, they designed 5G with security in mind. So there's a lot more security in fifth generation networks. And if we ever come out there again and do full class, we'll go into some of the security issues on 5G.
Yeah, we can't wait for that.
Yeah, we're gonna have to do that. We're gonna talk to Richard. Tell Richard that we need a.
He's here.
Richard here.
Richard is here.
I can tell Richard myself. I just told him. I said we can. I can tell Richard that we got to come up with some other classes here. How you doing, Richard?
Yeah.
Hey Steve.
Yeah.
Hey Steve. Hello Pete. I'm talking to you, aren't I? Hey Steve, you good? Hey Steve, you good?
Little colder here. This morning it was about 2 degrees below zero, so a bit colder than probably where you're at. So it's going fine here. It's going fine. This cohort is finishing up, and yeah, everything's going real well.
All right.
Just finishing up the protocols here.
Yeah, cool. Yeah. I won't interrupt your class, Steve, except for
Oh no, we're done here in about 5 more minutes.
Oh, okay. So we can borrow Raphael in 5 minutes.
Absolutely. You want to talk about 5 minutes?
All right. Okay. Cool. Good to see you, Steve. Good to see you, Steve.
Okay.
And I think it's just.
Do you want me to hang on after this? You want me to talk to you, or you need to talk to Raphael?
Yeah, he wants to talk to me, so I have to.
Okay.
See you later. See you later.
And also,
Take care.
yes, I'll reach out to you through discussion about how net access as well.
Okay. Now, one of the things before we leave, I want to mention something that's the last thing we'll look at, just kind of real briefly. To deliver data, to get data from here, right there in your mobile phone, over to here, as you probably know, a lot has to happen. You need radio reception, you need to be known in your system, you need to be billed, access, all these things have to happen, and all these things use a lot of different protocols. So it's not as simple as it seems when you take a mobile phone and you call someone, you take a mobile phone and type in www.anything.com. There's a lot that goes on, as you can probably tell. So one of the things that data is, one of the ways that data is handled in mobile networks is it's tunneled. And by tunneling, what does that mean? That means that you build these tunnels between these nodes. You build these data tunnels and you put a packet inside of a packet. You route via the upside packet, but what's inside has its own addresses, has its own destination address, it has its own source address, it has its own ports, it has its own data. So there's a lot of protocols that do that. I listed some of them here. These are requests for comments written by the Internet Engineering Task Force. So they write some. Well, 3GPP wrote its own. I'm gonna skip up a few slides here to this one. Why would you tunnel packets? Well, maybe you want to keep what's inside secure. That's one reason. Maybe you've got multiple packets inside of here, but you have one common routing packet. That's another reason. But the reason you do it in mobile networks is because your IP address is assigned, and as you go from different networks to different networks, as you move around, you don't need to keep reassigning an IP address to the mobile. You can keep your same IP address as long as you're in that packet data network. So that's the biggest reason why you want to tunnel these packets would be that reason. Now, I'm going to go up a couple slides again. GTP first appeared in 2.5G networks. It was the tunneling packet between the serving GPRS support node and the gateway GPRS support node to access the packet network. So when you use your network back in 2.5G, when you use your mobile phone, you could either use it for circuit services, like voice, or you could use it for packet services. Now this was slow packet though. This wasn't high-speed packet. This was very slow, maybe downloading an email or a document. If you were roaming, the gateway was in your home network, and you built a data tunnel to your home network, and then you access the packet network that way. So it first appeared, this tunneling protocol first appeared in 2.5G. It next appeared in 3G, kind of the same thing. It was a separate packet between the radio network controller, a separate tunnel, but you still had the same interfaces between the serving and the gateway. Local breakout if you're in your home network, home routed if you're a roaming subscriber. But 3G still had the circuit network also. By the time you got to 4G though, it was all data. And everything is handled on these tunnels in 4G. 4G builds a tunnel between cell towers. 4G builds a tunnel between the cell tower and the escape gateway. It builds a tunnel between entity and the S gateway. It builds a tunnel here. This tunnel right here, S8, and this tunnel are user data. So when you type in something, you're on your mobile phone now. You go out, you leave class tonight, and you want to do, let's make reservations at restaurant. So you type in www.restaurant.com or whatever that might be. That is picked up on the air interface. It's put through that www is put through a tunnel here. It's put through a tunnel here, and it's handed off to the internet here. So these IP tunnels will carry your data packets. If you're in your home network, you do this. If Raphael gets on a plane and Raphael flies back to Dublin, if this is the network that he's now in Dublin, this is his home network, the system will build a data tunnel in Dublin to the serving gateway in Dublin, and it will build a data tunnel from Dublin all the way back to Accra. And you'll access the packet network from this home network. That's called home routing. And I think that's as far as we need to go on GTP. GTP is also in 5G networks, but we'll talk about that at some other point.
Thank you very much, Steve. We are really grateful for us.
All of you have been great. You've been a group of people, and I have appreciated this very much. For a few weeks, it was middle of the night for me when I was in Ho Chi Minh City, but now it's the middle of the day. It's 1:30 in the afternoon for me back in Chicago. So it's a cold day outside, but everything's fine. And I want to say thank you. Thank you all of you. Thank you very much. And I mean this sincerely. I wish you all the best. Study hard, and yeah, you'll do great. You really will. So the best to all of you. And Raphael, if you have anything for me, we can talk next week or something too.
Okay.
I'll be around next week, okay? Okay.
Yes.
Thank you, everyone. Thank you very much.
Guys,
And someday I'll be in Accra.
Yes. Very well.
All right.
We are waiting for you.
Thank you.
So I'm really glad about you guys.